Hello. This is going to be a review of some concepts that are part of the AP Computer Science Principles course and that are tested on the exam. You can see here in bullets some of the concepts and topics that this video is going to go over. So let's see. First thing first, important to know, because this is what most of this video is going to be about, that the College Board has a simplified language that they're going to use on the AP exam. They're not going to test in a particular programming language like Snap or JavaScript or Python or Java or C++. They're going to use their own simplified language. You could refer to it as a pseudo language or pseudo code. It's uh, it's something that the College Board made so that they could find a simplified common way of getting every student, no matter what programming language they learned, to kind of speak the same language when they take the exam. And there's a reference sheet that is given to students. So at the end of the end of the exam, or I don't know if they rip it out, but basically on the left side of the reference sheet are all the commands that are part of the College Board's language, you could say, and on the right side is an explanation for what those commands do. They look different though than what you might see in, for example, Snap. Um, they don't look exactly the same. They use either different words for the commands. They might obviously even look less colorful because it's mostly text based. But what we're gonna do today is review, and we're gonna see that everything that you can do with the College Board language, you can pretty much do with Snap. Maybe one or two exceptions, but for the most part, there's a way to do everything, except sometimes it's not too easy or too simple. But for most of what is on the AP exam, it is possible to do in Snap with almost a one-to-one. For example, in this case, instead of using A mod B as text, you could use like a little variable A, the command mod, here it's a green operator, and then B. And so there's about a one-to-one with everything that exists in the College Board language and Snap. Let's get started now with this first one called display. So all display does is it's a command that right after the spelling out the command display, you put an expression, which could be text, could be a number, could be some sort of other expression that includes operations. And then whatever the result of that expression is, it's going to display it on the screen. So in this case, we're going to do a quick example of that by if in the College Board on the AP exam you see display hello world, what would that look like in Snap? To show you that everything that you can do with the College Board language, there is a way to do it in Snap. So all that's going to do is you're going to say uh, hello world. You can use the say. I think also the think kind of works. The ask kind of works as well in a way, but there's several ways to do it. The simplest way is to do it using the say. Let's see if this works. And it output hello world to the screen. Okay, that was pretty easy. Let's go on to the next one. Okay, the assignment statement. Okay, programming languages use variables, and those variables, there's got to be a way of assigning variables some value. Um, in the College Board's language, you're going to see this arrow pointing left. That is what is used to signify that a variable is being assigned a value, whatever's on the right. Let's go ahead and try that in Snap with this example down here that I put about city, state, year. Get rid of this. First, I'm going to create some variables. I'm going to use the script variables things just so I can kind of declare them all at once. But you can also use this make a variable to make global variables. Um, City, state, year. Okay, so I've got a city, state, year. And I've got to assign them. So how do you assign? You use something called the set command. So this set command, this set to, is like this arrow. So I'm gonna set city to the word Austin. I'm gonna set state to the word Texas, and I'm gonna set year to the number 2021. And then I'm going to actually output them to the screen. Say, actually need to use these declared variables over here. Let's try these out. Let's run this. Austin, Texas, 2021. It works. Okay, so kind of see there, College Board text space does a little bit different than these blocks in Snap, but it's pretty much the same thing. Next, that was the assignment operator. The plus, the minus, the divide, and the multiply, these are simply, like it says here, arithmetic operators. You learned these sometime in elementary school, and they're used by programming languages. So we're actually going to try them out and see how they work here. Let's go ahead and try. First, what they do here is they declare, how many is that? 1, 2, 3, 4, 5, 6. So there's 6 variables that are going to be assigned some value. So let me get rid of this. Let me get rid of this. And this. And start over. So we've got a script variable. We got a variable named X. We got one named Y. We got one named sum. Difference. Huh. I feel like I'm running out of space here. Product. Quotient. Okay. So I've got my script variables. I'm going to then assign some values to this X and Y. As we see here, College Board uses that arrow pointing left to assign. We use the set to assign a value to our variables. So I've got an X and a Y. 17 and 5. Then I've got some difference, product, and quotient that are being assigned a result of an arithmetic expression. So let me pull out 4 of these set commands that, as I mentioned, are like the arrow pointing left in the College Board's language. And let me get an operator. So these are the operators right here. Oop, no, that's not what I wanted. I wanted this here. Minus. And then I'm gonna display the 4 of them. So actually, let me see. X, Y. And then after these are assigned. So what's gonna happen is on the right side is some sort of expression that's gonna, I'm basically showing this to show how to use these arithmetic operators, but you can also kind of see how on the right side we have an expression being set here in Snap, here in the College Board's way of doing it, and on the left side is a variable that the result of that expression is assigned to. And then it wants me to display them, so let me. I don't want to lose that PowerPoint presentation, otherwise I would make this full screen. I don't think I would, but I don't know, I'm not too familiar with this whole thing. All right, let's see. sum difference product quotient. So let's see, it's should be 22, and then 12, and then what's 17 times 5? Let me see. Can I get a calculator into this? 17 times 5 equals 85. So it should be 85. And then over here, I got this example from here. It should be 17 divided by 5 is 3.4. So let's run this and see if those are actually the results. Oops, let me stop. Let me start again. Should be 22, 12, 85, 3.4. Okay, so it worked. There is a way to do these commands that the College Board has and that you'll see on the AP exam, how they work in Snap. Okay, next. Data types. This, if you see this in blue right here on these PowerPoint slides, all that means is this is coming from the College Board themselves. You can consider this gospel. This is like College Board says this is what's true, and this is their official way of defining things. According to them, programming languages have data types that include numbers, booleans, lists, and strings. A string is an ordered sequence of characters. In Snap, numbers, text / strings, text and strings are the same thing. Because a sequence of characters could be like one character, right? Even one is a sequence. So it could be a character, one letter. It could be a word. It could be a whole sentence. It could be a whole paragraph. All of that counts as a string or text. And booleans. These are all like primitive data types that are types inherent. They're like the most basic parts of Snap. Boolean, College Board defines as either a true or false value. Numbers, infinite numbers could exist. With text and string, same thing, right? You can think of any number of combinations of possible strings, words, letters, sentences. Like you can go on forever thinking of different types of text. When it comes to Boolean values, it's only ever going to be one of two possibilities. It's either going to be true or it's going to be false. It's like no in between, either true or false. So you could think like, it's raining. Is it rain? It's not raining outside, so that's false. There's no like in between. Relational operators. So one of the reasons I mentioned Boolean is because we're going to go over relational operators, and relational operators result in either a true or false. All of these, for example, that you might be familiar with math, this is equals, this is not equals, greater than, less than, greater than or equal to, less than or equal to. They all tell you about the relationship between two numbers. It tells you, is the number on the left equal to the number on the right? Is the number on the left greater than the number on the right? And all of these will result in true or false values, Boolean values. Unlike, say, the arithmetic operators resulted in numbers. For example, 2 times 2. When we say 2 times 2, we get, what's our result? It's a number. When we say 2 equals 2, the result is true. We get a Boolean as a result. So I'm just going to do a quick demonstration of that to show that two plus two gives us an arithmetic result, a number result. 2 equals 2 will give us either a true or a false result. Okay. Let's see. Oh, well, let's actually try this out. It wants to display these. So let's get rid of all this and program this. We've got say, which is like the way that snap does a display. And then let's get our relational operators. Let's get a greater than. So I don't think snap has a native greater than or equal to, less than or equal to, but you can make your own. There might even be a way to import them. I'm not sure. It's not really important for the purposes of this. You can you know what it means. So when you see it on an AP exam, on an exam, you'll see like a greater than or equal to or a less than or equal to. You know what that means. Okay, so let's see. 10 greater than 5, 10 equal to 5, and 10 less than 5. In this case, is 10 greater than 5? Yes, it is. 10 is greater than 5, so we should get a true the first time around. Is 10 equal to 5? No, it's not. So then we should get a false. We should get a true, then a false. And then lastly, is 10 less than 5? No. So that's false. So it should be true, false, and false. Let's see if that's what we get. True, false, and false. Well, you couldn't quite tell there, but it actually it did it. But I'm just gonna prove it to you by running it individually. See, that's a false. Okay, so that worked. Next, those are the relational operators. Not. Okay, these are Boolean operators, and they're different from the arithmetic operators and even the relational operators in that the operators we saw, the arithmetic and the relational, what did they use in their expressions? Not what the result was. The result was different. One of them had numbers as a data type, the other one had Booleans as a data type, as a result. But the actual operands, like if you say 2 times 5, times is the operation, 2 is the operand, 5 is the operands. The operands were numbers. Well, for our Boolean operators, our operands are going to be Booleans. The three of them are not, and or. Those are the three Boolean operators, and you can pause this and kind of read this slowly if you want to, but I'm going to go to a table that kind of gives a quick overview explanation of what each of these does. The and takes two operands. So it's going to have like something on the left side, the word and then something on the right side. And it's going to look at them and give you a result based on what, are they true, false, and how does it determine that result? If both of the operands are true, it returns a true. If even one of the operands is false, the entire thing is false. For the or, as long as one of the operands is true, then the entire thing can be considered true. So if they're both true, great, true, because at least one of them is. True or false? Well, it's true because at least one of the operands is true. At least one of the sides of the or is true. Or false or true? Well, one of the sides is true. That means the entire thing is true. Look at the and. The and, even if you have true, simply because one of the values is false on one of the sides of the and, the entire thing is going to result as false. And finally, we have a not, which just gives you the opposite. If you say not true, that's false. If you say not false, that's true. Let's see how this actually works with code. Let me see here. We're going to program this. Let's see. Try the following. I'm actually, this does not say to display them, but I mean, there's really no point in, actually, yeah, we don't need to display them. So let's see. Or, if we say, notice how the left side and the right side are going to take a relational operator. And what does a relational operator give us? It gives either true or false. That means that this or is going to be operating on Boolean values, not numbers, like you see over here. So that and then another greater. So we have two greater thans. So in this case, they're asking 5 greater than 1 or 7 greater than 9. Now, is 5 greater than 1? Yes. So this is going to result in a true. The left side is going to be true. What about the right side? Is 7 greater than 9? No, it's not. So this is going to be false. So this is effectively true or false. And remember, as long as one of them is true, the entire thing should be true. So this should give us back a true value. Let's see if that holds up. And it does. Despite the fact that the right side was false, because at least one of them was true, the entire thing was true. Okay, let's go ahead and get an and in a bit we're gonna need a not. So now, what would happen if one of the sides was true, but the other one wasn't, and we, instead of using an or, we used an and? Remember, for an and, both sides need to be true. So in this case, we're going to get a false because the right side is false. 7 greater than 9 gives us a false, which means that even though the left side is true, the entire thing is false. And now let's try one of these with a not. So let me ask you, is 5 greater than 1? Yes, it is. But we're going to perform a not operation on this true. So not true means it's false. Let's try this. So what is the not false? True. Okay, so that was the or, the and the not, these Boolean operators. Let's now go to if else. So if else is a type of command that introduces selection into your program. Selection meaning that it allows you to branch off and do certain things and skip others based on whether some condition is true or not. That this is how College Board officially defines it. We're gonna actually like do an example in a moment to see how it works. In the College Board's language, you can read through this, pause and read through this, but basically an if statement, if there's an if statement in a program, it either gets executed or it doesn't. If you have an if else statement, then something is going to get executed. If the condition is true, the first part gets executed. If it's false, the second part gets executed. So when you have an if else, you kind of can't escape it. You're going to have to execute something. The question is, are you going to execute the first part or are you going to execute the second part? If you have a simple if statement, then it's possible you skip the whole thing. If the condition is false, you don't execute any part of that at all because it's only one part. Let's go ahead and try this out. And one thing to note is that in the condition part of our if statements, like we say here, if, and then you've got your condition, and then it displays. In the condition, that evaluates to either a true or false. You can't have if, hello, or like, text, or if just the number 10. You need some sort of expression that evaluates to a Boolean value of true or false. Because the condition, that's what's going to be checked. If the condition is true, if whatever's in there evaluates to true, it's going to execute whatever's inside the if statement. So enough talking, right? Let's go and do this. It's a if ten is greater than 5, say hello. And then if 10 is less than 5, say good day. So this very simple scripting program decides, is it going to say good day? Is it going to say hello? It could potentially say both if both are true, right? No matter what, it's going to check each if statement individually and decide whether to run it or not based on whether the condition is true. So this first one, Is this condition true? Is 10 greater than 5? Yes, it is. So this should say hello. Is 10 less than 5? No, it's not. So it should skip this completely. Let's see if that's what happens. It says hello, goes to the second if statement, decides this condition is false, so it doesn't execute it. Let's see. Is 2 less than 5? Yes, it is. So now both conditions are true. It should say hello and then say good day. And so as you can see, let's see, 10, let's put 10 in here. It's possible that um both if both are false, 10 is not greater than 50, 10 is not less than 5. It's possible that in that case, I clicked on it and ran it, and my program skipped both if statement blocks, like the block instructions part of the if statements, because the conditions were false. You'll see right now that you can't do that with an if else. With an if else, something's gonna get run. So let's actually try an if else, and I think I have something over here. Okay. So let me see. I need a variable named grade. I'm gonna set it to 65. If 70 is greater than whatever the grade is, I'm gonna say I passed, else I'm gonna say I bet. So let's actually try this out. So we have a variable named grade that we declared. We set it to 65 as a value, and then this checks. If 70 is greater than whatever our grade is, I'm going to say I passed, otherwise I'm going to say I failed. So this should say I failed, right? What? 70? Oh, if this is, if grade is greater than 70. Okay, so that's where my mistake was. Is a grade, yeah, wouldn't it be great? Okay, so let's see. If 70 is greater than 7, I failed. Now, as you can see, what if my grade is like an 80, right? Then I'm gonna say I passed. No matter what, one part of this is happening. Either this first part in the if or in the else. Something is getting executed based on whether this condition is true or false. Okay, let's go on to the next slide. Procedure. A procedure is a tool that programmers use in which they, you could say, put together a bunch of statements, programming instructions, and kind of set them aside. And then whenever they want, they define those and they give them a name. And then whenever they want to execute all those instructions, they simply call the name. Okay. And I'm going to show you an example in a moment. There's a little typo here. This greeting, it should say hello, because I'm defining a procedure and then I'm calling that procedure. In Snap, and by like different programming language has different name for this. Could be subroutine, procedure, method, function. In Snap, these are called blocks. So in College Board, you'll see in the AP exam, you'll see questions that have their own procedures defined. You can think of that as, okay, in Snap, how were procedures defined? It's whenever I made my own blocks. So instead of making their own blocks, they're making their own procedures, but it's the same thing. So we're gonna do this first one very quickly, very easily. It's a procedure named say hello. There is no return or report thing going on here, so this is simply a procedure that performs an action, which in this case we would refer to as a command procedure or a command block. So it's going to be a command. The command's going to be named say hello. Although procedures can take parameters, and as Snap users, we can make our own inputs. In this case, this example does not have any. It simply is named say hello. And what does this thing do? It says hello. Oop. Let me see. It says hello world, and it says I want to hello world. And while I'm at it, I'm gonna go ahead and just add some flair to this, just to show you that let's see. Let me add a script variable. Let me add an A and a B. A to 5. Well, it's not really flair, but just more instructions to show you what's going on when a procedural block is created, to demonstrate one of the important aspects of this. And then I'm gonna set C. Oh, let me make a C variable to A times B, and then I'm gonna go ahead and say, let me get my join. A times B is, let me apply, okay. And so now I have a procedure or a block defined, and it's gonna, how many lines of code is this? 1, 2, 3, 4, 5, 6, 7 lines of code. I'm gonna click on this, I'm gonna execute this. It looks like one line of code, but what happens is when this one line of code is executed, it actually goes and looks for those 7 lines of code that are hidden and executes all 7 lines of code. So it's saying hello world. Since I want to learn to program, 5 times 10 is 50. So what's the advantage of doing this? Well, let's say that for whatever reason, I needed to repeat this process in a program that I'm making 5 times. Well, I can do that. Maybe add some other commands, maybe some go-tos, some glides, random things. And then I want to say this again. I want to perform these actions again. Let's say I do this like, I don't know, 10 times, right? And I execute it. Okay, well, I can do that. But isn't it getting like a little messy? Like there's a lot going on. Why not simply do this? Where was it? Instead of having these 7 lines of code repeated over and over, no need to repeat that code all over the place. Simply get your say hello procedure and use that to call on these 7 instructions to be executed. This is what is called detail removal. One of the important, what we're doing here is called procedural abstraction. There's 2 main components to procedural abstraction. One of them is detail removal, the other one generalization. Well, the important thing here is the detail removal. We're removing the details of this procedure called say hello. We're hiding the details. Like looking at this, like if I have somebody helping me my programming, then they come here and they see say hello, they don't necessarily know what's happening inside the procedure, inside the block say hello, but they don't really need to know what's going on in order to be able to use it, because every time we call on it, it executes those instructions. This is abstraction in action. Okay, so let's see. Procedures. Important things to know about procedures. You can pause and kind of read all this. Is all coming from the College Board, but we're already over 30, way over 30 minutes. So I'm just gonna skip this part and you can pause and read it. Two things I do want to point out though is procedures. This is what they're called in the AP exam. Method, function. In Snap, they're called blocks. Just get used to the word procedure. but in other programming languages, they may be called something else. Other thing is they do help you do less of duplicating code, right? Instead of duplicating code, you use the same sequence that you the same block of code uh, statements that you put together over and over with this one little line. Okay. And one final thing to mention. In computer science and programming, we do a lot of programming of algorithms that we've created. So we create the algorithm and then we implement those algorithms when we program. These algorithms have three basic building blocks. One of them is sequencing, and that is making sure that the instructions, the commands that we program are in the right order. Quick example. Let's say I go here, say hello. What if I were to put this, say, over here? Let me apply. Okay. Well, I execute that. And then what happens? There's an error. Why? My sequencing is wrong. I need to declare my variables, perform my operations, and then output the result. Not output the result first. So sequencing, important building block of algorithms. Iteration, all that means is loops, repetition, when you use a repeat, when you use a repeat until, when you use a for loop, all of that is iteration. And finally, selection, which we reviewed in this PowerPoint. If and if else is primarily how the College Board sees selection. Technically, a repeat until has selection. There's other blocks out there that also have kind of like inherent selection built in. And all that means selection means is a code branches or has the ability to branch based on a condition. So it decides to execute or not execute based on whether some condition was met. But from the College Board's perspective, you kind of think if or if else. Okay, so that's it. Thank you. What?